Hello, and thank you for buying the Scrolling Altimeter asset. In this tutorial, I will show you how to import it and use it. I have an empty project here in Unity 6.1 in the URP pipeline, and you can import the project through the package manager. As for me, I have it on my hard drive, so I will import it by going into Assets, Import Custom Package, and select the package from my hard drive. In any case, you will get this import window, and you just click on Import and wait until the asset is imported into your project. When it's done, you will find the 3D Lunatic Productions folder in your assets, and underneath it will be Altimeter and all of its associated subfolders. The prefabs include Altimeter A, B, and C, and let's take a look at how you can use them in your scene. So when I first grab a prefab and drag it into my scene, it might say Import TMP Essentials if you haven't already imported TextMesh Pro. This is a free asset by Unity which handles TextMesh Pro text. And so we click Import TMP Essentials. It will create the TextMesh Pro folder under your assets, and you can close this. Now we can use the TextMesh Pro fonts that are used in the Altimeter asset. But we still cannot see the asset. The reason is it's a UI asset, so you have to create a canvas. So go to UI, Canvas, and it will create a canvas and an event system which drives the canvas, and then drag the altimeter under the canvas, and then it will become visible. You can move the altimeter to where you like on the screen. So for example, over here, let me see, I moved it too far. Oh, okay, I have it back. Okay, let's move this one here. Let's grab all of the prefabs so you can see what they look like. Move that under canvas. This version we'll put somewhere like here. And this version we will put somewhere maybe over here. So these are the different looks that I created, but I also included the PSD file where you can create your own frames. It will have the display area already masked out for you, and so you can use it as a guide to create the frames in the correct size. All right, so how do we hook them up? We need some kind of object to track. So it could be an airplane. In our case, let's just create a cube. So I will change my scene to 3D view and create a cube. Let me zoom in on it. Okay, here's our cube. And since we have multiple altimeters, then let's create some other objects as well. So create a sphere, and then create a cylinder. So these are the objects that we will want to track. So in Altimeter A, notice in the inspector there is a field called Tracking Target. This is where you drag any game object that you want to track. So in this case, it's our cube, but it could be your airplane or aircraft. So I'll drag that here, and that's all you need to do. In Altimeter B, I'll grab the sphere and track that. And Altimeter C, I will track the cylinder. So now, if I press play, of course the objects are not in view of our camera, so maybe I should adjust my camera's view, but I will grab the cube and just move it around, and you can see the altimeter for the cube is adjusting the altitude. Likewise, if I grab the sphere, the other altimeter is adjusting. If I grab the cylinder, the third one is adjusting as well. So this gives you the height above sea level, which is y coordinate of 0 in Unity. And it goes down into the negatives as well. So you can go infinite amount up or down, and the altimeter will display the correct altitude. It does not track the altitude from terrain. To do that, you would need a different system which casts a ray from the bottom of the object that you're tracking and then calculates the height above the terrain. But in general, altimeters work on height above sea level anyway, so this is more correct. Now imagine you want to track one of these objects in terms of feet instead of meters. You see, feet is the general standard in aviation. Meters is a default unit in Unity. So I included a checkbox in the inspector. You can click track in feet. You don't have to scale anything in Unity. You don't have to rescale your scene or objects. It will simply convert the measurement in meters to feet before displaying it in the altimeter. Now here I have a little scene I created to demo the different altimeters, and it has an airship or a spaceship that I created with some simple controls to navigate. In the canvas, which in this case I call the airship HUD canvas, I included the 3 altimeters A, B, and C. To make them work, I simply grab my airship, which is my flying object, and drag it into the tracking target field for each of the altimeters. I want them all to track the same airship. Okay, and for the middle one, I want that one to track it in feet. So I will click the display in feet checkbox. And we are ready to try it out. Now, I have not created ground collisions yet, so the ship is going to sink through the ground, but that's a good opportunity to show you that the altimeters also can handle altitude below 0. So let's hit play. And my airship is sinking because it doesn't have power to the grav coils, which is fantasy technology I'm using. So now it's underneath the city, and you can see the altitude. In the left and right altimeter, it's the same, but in the middle one, it's in feet. So left and right is measured in meters, and the middle one is in feet. So let's give it some grav coil boost to make the ship go up. And you can see the altimeter in feet is moving 3 times as fast because there's roughly 3 feet to a meter. Of course, it uses the correct measurement for the conversion. So you can see it's going up. I'm going to give the ship some boost forward. Forward doesn't matter because the altimeter only measures height, not speed forward, but let's move it around a bit. And you can see how the altimeters are all working. Now, don't mind that this is a very simple demonstration, so I don't have clipping. If we happen to go through a building, nothing really will happen. But at least you can see that the altitude readings are correct. Let's go through this building. Yeah. Back to the landing pad. Now let's take a look at some of the ways you can customize your altimeters. So let's first take altimeter C, that's the right one, and expand its contents. So there's the background image. And let's say I want the display to be sort of like green lines on dark green background. So I will change the background color to something like dark green. Okay, let's say like that. And then the graduated lines, I want to make those bright green. So you just click on the color field, you select the color that you like, so maybe this one. And I want to use exactly the same color for the text, so I will copy the code. And these 3 text fields are the numbers. It's very clever the way it works, because when they scroll out of the display area, they get reused, they get shifted to come back in from below and vice versa. So I will change their color as well. I'll just paste that green color in there, so it's kind of like greenish display. And now let's say we want to change the color of the hairline. And I want to make it, I don't know, some purple color or something like that. But I also want it to be thicker, so you can change the height of this image. So let's make it like 4 pixels instead of 2. Okay, that's thicker. You can make it even as thick as you want, like 8 or 50, whatever you want. Okay, so we just changed the look of this display. You can do the same thing for the other altimeters. The other thing it has is a frame. And so for the frame, I created some materials. So there's altimeter frame A, B, and C. You can find the textures for them in the textures subfolder. So you have the frame A, B, and C. These are the ones I made for you. You can make your own. The PSD file is included here called frames. And if you're familiar with Photoshop, you will find all the necessary layers, including the display screen mask, so that you can make the frame the correct size. The frames should be saved as PNG images with transparency, and they should be 512 by 512 pixels in size. So if they're this size, then you won't have to change anything in the frame settings. See, the width and height are set to 512 here. If your frames are a different size, you will have to adjust the width and height to the actual size of your frame image. I think that about covers most of the customization. If you want to change the scale of the altimeter, you can use the scale. I would set it to uniform and then change the scale to like make it smaller or bigger if you wish. But if you keep it at 1, then it will be pixel perfect. So basically, it will be 1 pixel corresponds to 1 pixel in the actual images, the textures. So there won't be any blurring or like softness. Okay, lastly, let's take a look at the components, the 2 scripts driving the altimeter. So the altimeter controller is the script that displays the lines and the numbers, and you shouldn't really change anything here. For example, the pixels per meter and tick spacing pixels, it's the correct space for the graduated lines image, which is also provided for you, so that the altimeter scrolls at the correct amount when you change altitude. The labels correspond to the text labels. None of this should really be messed with. The only thing you might want to do is, instead of using this other script, Altitude Reporter, to track the altitude of a script, you might want to use it through code if you're a coder. So you could just delete this component. This component is what grabs the altitude of the target, tracking target, and converts it to the reading. So instead of using that, you might want to send the altitude as a float to the altimeter controller in your script. So if you want to do that, please look into the documentation, and I indicate the setter method, which is the public method in the altimeter controller script, which allows you to send it the altitude that you want it to display. And that pretty much concludes the tutorial. If you have any questions, feel free to contact me. You can find my email address in the documentation as well as on the Unity Asset Store. Thank you.